While incoming data has been validated based on rules, this is just half the story. The next aspect is with regards to profile. So let's set the stage on what we would like to look at. If you ever dealt with data pipelines on a daily basis, you are aware that the volume of data is a very good indicator of the health of a pipeline and the state of a particular pipeline. If I was working with a particular pipeline and I noticed that every day I create about 1 million records, give or take a few 100,000, then I'm pretty confident that my system is working as expected. However, in the latest refresh, in the latest run, I give out, say, 3 million as opposed to 1 million. That's a huge red flag. Most likely my join conditions are breaking. There might be duplicates and a slew of other problems causing this huge increase in the volume. And for that, and not just that, aggregations can come from multiple locations. Volume is just one of them. You can have nulls, duplicities, patterns, distributions. For all of this, tracking of all of this and keeping track is what we have profiling for. So what do we do in profiling? Well, in profiling, as you can see, we don't not only understand the entire profile of the data with regards to the distribution of the data across different values, the alphanumeric patterns that we are working with, but we also keep track of these aggregates day in and day out. So for every run, we keep track of the associations that we are working with. And if something is amiss, we call it out as an anomaly, saying that, okay, this is something that we see as an incoming issue. In this case, the mean of this particular data set has dropped drastically. And that is an issue for my particular system because I'm not expecting this. Along with that, as you see, the result of this particular profile itself is a data set. So as you can imagine, if I go back to my SQL node, you see profiling in itself is a data set. So if I want to apply another set of rule sets or anything on top of it, I can do that as well. And now let's discuss a bit on observability. So I've created a couple of examples which I want to illustrate. So I'll open both of them together to illustrate what we are trying to look into. So let's open up profiling right here. And let's also open up a Tableau use case, as this is going to be helpful in visualizing the data or the anomalies that we are trying to work with. So let's get started. In this use case, I am representing data that you're seeing with the line chart. So that's the main reason we're switching over to Tableau. This can be done for incoming data as well. Tableau just illustrates that, what the data looks like, so to speak. So what are the two key problems in realistic data that we see in the line chart? Well, firstly, I'm working with seasonal rises and falls. Now, data is inherently seasonal in a lot of ways. Your sales are going to depend on that you're working with. So there can be periodic rises and fall, and there could be multiple periodicities with that. You can have yearly, weekly, daily, and so on. And understanding if this particular rise, the red spikes that you see here, are these yearly or weekly spikes, or are these an actual anomaly that should not be within our data? That's the first problem statement. The second one is the fact that, well, it's not just one particular line. There are 3 categories within this chart. And that's the truth. If you look at just an average of sales, the product that you sell the most is going to overpower everything else. So your categories, certain categories are going to be, well, underrepresented in your profiling systems or your anomaly detection systems. And not just that, the truth of the matter is that these categories could follow entirely different curves. An easy example here would be in terms of pharmaceutical sales. Say you're a pharmaceutical company and you're trying to monitor your sales, and you have sales for both, say, flu medication as well as diabetes medication. Flu medication is obviously going to have different sales based on the flu seasons. It's a seasonal cycle sales. However, diabetes is, in contrast, a much more stable sales cycle in terms of, say, what you are going to push ahead with that. So there you want to make sure that if there are anomalies in diabetes, if something is going amiss from a stable value, then you want to capture that. And with regards to the flu medication, if you're expecting a rise and that rise isn't here, that's an anomaly. So different algorithms for different categories. And to illustrate this, we have observability. So what do we do in observability? Well, we just define what these categories are. Again, similar to the rest of the system, everything is zero code after all. We drag and drop the corresponding metrics that we want to run comparisons against, or in this case, run some validations against. Statistics as of date is an optional column. If you do not provide this, each and every run is considered its individual data point in time. And then you select the prediction method. Time series, of course, is the specific use case that we are dealing with. However, there are a few more that you can work with. You can change these parameters as well if needed. And in the results, you will see two sets of algorithms. The first one is, as you can see right here. Look at the y-axis. We are between -100 and 200. This is a relatively stable value. So a peak of 381 and 390 has been defined as an anomaly because we were not expecting this based on the previously trained data. In contrast, if I look at regular air, this is much more volatile. The y-axis is jumping from -200 to 600. And so here, something as high as 620 itself is not an anomaly. In fact, it's a base value, but something as high as 855 can be deemed as an anomaly, especially subsequent repeated spikes, which were not expected based on the previous data set here. And so in this manner, what we have done is that we have analyzed the data based on the dataset itself or by multiple datasets over multiple batches. And we have defined different set of algorithms to run for different categories to call out anomalies across a spectrum of aspects.
For further questions, feel free to reach contact@datagaps.com. Request a free demo, scan the QR code below. Thank you.